1.
Hello everybody, welcome back again. I am going to go over Chapter 8, Lesson 4, called Multiple Representations of Functions. So as you can see on my whiteboard here, we're going to take a look at a function in words, and then we're going to translate those words into an equation. So as we read through the problem, pay attention to what could be the input or the x value, and what could be the output or the y value. So we have this situation. A runner's distance in a marathon is equal to 8 miles per hour times the number of hours. So I have a feeling now about what the problem is. I want to get a little more detail out of it, so I'm going to read it a second time. So we know a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. So I have an unknown here. My unknown is, I don't know how many hours this runner's going to run. I do know that they can run 8 miles per hour. So 8 miles per 1 hour would mean 16 miles in 2 hours. In 3 hours, that would be 8 times 3 is 24. So I'm going to take this runner's distance. The distance is going to be equal to 8 times the hours it runs, or the person runs. So for example, let's say a person runs for 1 hour, the distance would be 8 miles. If a runner runs for 2 hours, the distance is 16 miles, and so forth. Okay, let's take a look at another function in words, and we're going to translate that into an equation. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation for finding the total amount earned, and they gave us the variable t for total, for selling P pies, and they gave us a letter P to represent our unknown pies. So instead of using an X for an input and a Y for an output, I have to think about what is happening in this situation. They're charging $5 for each pie, for each P. So $5 per pie would be my 5P. 5 times 1 is $5 for 1 pie. If P were 2, they sold 2 pies, it would be 5 times 2. So what is it that 5P is really representing? It's really representing the total, or T, how much they're going to earn. So T equals 5P would be the equation that represents that sentence. Okay, let's take a look over here at the next screen. And we're going to represent functions using tables and graphs. So read along with me. The student council is holding a car wash. They are charging $7 for each car they wash. Write an equation and make a function table to show the relationship between the number of cars washed, so we have a C that's going to represent the number of cars washed, and the total amount earned, which will be T. So they've given us our variables. My input, my rule, and my output will be part of this function table. So my input is, it's either going to be how many cars are washed or what the total is going to be. I think my input should be how many cars are washed, because imagine if they washed 1 car, 2 cars, 3 cars, or 4 cars, that would be my input. So my input is cars washed. Instead of writing an X now, we actually have a variable because it's part of a situation. I'm going to wait for my rule. My output is how much they're going to earn. So this is going to be T for total earned. I'm gonna look back into my problem to see what my equation is. I can see up here they're charging $7 for each car. So my rule is gonna be $7 for each, C stands for cars, 7C. So I'm gonna take my input, plug it into the rule to get my output. So if I have one car washed, there's my 1 times 7, or 7 times 1, either way. For that one car, they're gonna earn $7. Okay, if they wash 2 cars, I'm gonna do 7 times C. My C is 2. 7 times 2 is 14. They earn $14. And I keep going through this until I have enough coordinates to graph this as a linear function. So if they're washing 3 cars, $7 per car, $7 for 3 cars, they would earn $21, and then $7 for 4 cars, that would earn them $28. Okay, the next thing I'm gonna do is I'm gonna graph the ordered pair. Before I do that though, what is my equation? The output is T, so how do I get T? I multiply 7 times the number of cars, so T equals 7C is my equation. So down here on my graph, I'm gonna get some ordered pairs out of here. And as you can see, this would be my input, that's my output. So my first ordered pair is 1, 7, then 2, 14, 3, 21, and 4, 28. Now I have to decide what axis is this. This is my x-axis, but this is actually the cars washed. So this is cars washed. And this is my y-axis, but in this case my output is T, or total earned. So I'm going to graph these cars washed 0, 1, 2, 3, 4, 1, 2, 3, 4. And amount earned, it's going to be 7, 14, 21, and 28. Now I can plot my points. Over 1, up 7, over 2, up 14, over 3, up to 21, and over 4, up to 28. Once I connect these dots, which should be a little more like a line, you will see that this creates a straight line, a little off there, which is my linear function. So to wrap this up, I can represent functions using the table, the graph, words, and equations. Thanks, everyone.